Hey, Algebra 2s, let's go ahead and tackle this homework, and why don't you join me in making my key. So I want to make sure that these perfect squares are in the front of your brain, and your calculator can really help you. I want you to think about this. Y is equal to x squared. If each of these numbers went into that, what would come out? If your calculator is necessary to help you, go ahead and go to your function screen, type in x squared, go to the table of values, and look, there they are. But what I want you to be able to do without the calculator is be able to think about, okay, 1 squared, 2 squared, 3 squared, 4, 5 squared, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. Hey, these are your best friends. These are people, these are the numbers you invite to your birthday party. These are the numbers you're excited to see in all your math problems because you know you're looking for special patterns. When we move on to the cubes, you're thinking about this equation. What output is from each of these numbers cubed? So I've got some of these in my head. 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. Oh, I might have reached my limit. But I'm not worried because I can go right back to my calculator again. And this time, instead of asking for x squared, let me ask for x cubed. So I can right away look at, there's my 8, my 27, my 64, 125. I knew I wasn't right. But I'm going to go ahead and keep these on my page. 216, 343, and 512. And as I keep going and looking, 729 and 1000. It's nice to have these numbers, and wait till you see how often you end up using them. All right, factoring each expression. If not possible to factor, go ahead and write the word prime. This is the difference of two perfect squares, x plus 3 and x minus 3. Here's the sum of two perfect cubes. So I'm going to go ahead and take the time to say, okay, A is equal to x, and B is equal to the cube root of 64. 1, 2, 3. Oh, that's going to be 4. So I'm going to go ahead and draw my binomial pair and my trinomial parentheses, and I'm going to use SOAP. Same sign, opposite sign, always positive. Here's my A and my B from here. And here I have my A squared, my B squared, and then A times B is 4x. So you want to make sure that you do lots of practice to make sure that that pattern makes sense to you. The reason why it's worth finding your A and your B is always because you have something like this. So the cube root of 8x cubed is going to be 2x, and the cube root of 729 is going to be 9. Once I have that A and B there, it makes it easy for me to draw my binomial and then my trinomial parentheses, same sign, opposite sign, always positive. So here's my A, here's my B, and here's A squared, here's B squared, and then A times B is going to be 18x. So it's nice to know how that fills in following that pattern that we talked about in your notes. All right. So it becomes real important for you to pay attention to what you're looking for. And as you're doing this homework, think carefully about, is it a squared or a cubed? A cubed or a squared? A cubed or a squared? A cubed or a squared? But we want to make sure that we pay careful attention to this one because it's got a cubed, but we also have that GCF that we have to think about. And so we're going to pay attention to these as we go. All right, so when I have the difference between two perfect squares, I'm going to go ahead and draw my sum and difference pattern. And I know the square root of my A term is going to go in my first spot, and the square root of my B term is going to go into my second spot. Now for this one, I want to be careful because remember we talked about that GCF, and we want to be sure that we pull it out. When I see this negative out front, we're going to take the time to write it as x cubed plus 125. So that changes both signs when I pull it out. So that negative is going to hang out outside of my binomial and my trinomial pattern. Let's talk signs. Same sign is plus, opposite, always positive. My A in this story is x, and my B in this story is 5. So it's going to be x plus 5, x squared, and 5 squared go in my two outside positions. And then I'm going to multiply these two values together, 5 and x, to get that middle term. All right, let's take a look at this one. When I have x cubed, I'm going to go ahead and take a look at that. A is going to be the cube root of x, and B is going to be, the cube root of 4. That's not a number that's in my list, and that's not a friendly number. So I'm going to go ahead and call this one prime. I can't factor it. I can't break it down because 4 is a perfect square. 4 is a part of this list, but not this list. All right. So now we're getting into some tricky ones, and we want to make sure that we pay attention to each of these coefficients. These are perfect squares. So splitting these up is easy. It's a square, so it's two binomials, and it's going to be 5x plus 7 and 5x minus 7. Not a problem. But when I come over here, I want to make sure that I factor this 6 out, giving me x squared minus 100. All right, now I'm in good shape because now I recognize 100 as one of my best friends, x plus 10 and x minus 10. So remembering to take care of that GCF is going to be super important. Same thing's going to happen here, but I'm going to be careful about what I divide out, and I want you to think about why it is I'm only dividing by 2. If I factor a 2 out, that's going to leave me with 1,000 x cubed minus 8. Here's what I love about 1,008. Do you see how they're each in my friendly numbers? So this 8 here, you can blow him up, and this 1,000, those are the perfect cubes. Those are my best friends. Those are the numbers that I look for when I'm doing math. So this 2 hangs out as a coefficient. Here's my binomial, and here's my trinomial parentheses. Let's go ahead and do our signs. Same sign, opposite sign, and always positive. So my A value is going to be equal to 10x, and my B value is equal to 2. This is so helpful for me when I'm filling in the values into the pattern, because my A goes here and my B goes here. My A squared, 100x squared, my B squared, and then my A times my B, so 20x. So in case you're curious about what that pattern is, you can go back to your notes, or I'll write it right here for you. So here's your A, and it's going to be plus or minus B, depending on these signs. And then we have A squared, and it's plus or minus, depending on the signs, A times B. And then this is always positive for B squared. So that pattern becomes important. Make sure you know that. This one we did already. Now we're going to go here. I'm not sure about 512. I know 27 is familiar, so I'm going to go back up to my numbers. I'm in good shape, so 512 is a good one. So we'll go ahead and say that A is 3x and B is equal to, let's see, here is 10 cubed, 9 cubed, that must be 8 cubed. So 512 is going to be 8 cubed. So I'll set up again my binomial, my trinomial pattern. Same sign, opposite sign, always positive. So I have 3x for my A and 8 for my B. A squared is 9x squared. B squared, 64, and A times B, 24x. All right, so I have a square, and it's a binomial, so I'm thinking about the difference of two squares, but guess what? I'm checking out this plus sign, and I know the sum of squares. Guess what? We know what's true about that. It's always prime. So that is something I cannot factor. All right, we're going to get into this one. And I told you to think ahead about this one. I hope you saw what I wanted you to see. Hello, GCF. So I'm going to take an x out, and that's going to give me x squared minus 64. Now I have the difference of two perfect squares. I have x times, and I can split into my sum and my difference pattern. We love 64. Check out 64. 64 and 1 are our two numbers that are both perfect squares and perfect cubes. So those are numbers that we're going to see a lot. Very familiar. All right, so we're going to go ahead and do x and x plus 8 minus 8. All right, here we go. True or false, the sum of squares is always prime. That is going to be true because the sum of squares cannot be factored. And we're going to talk about this a little bit more in detail when we dive more into quadratics. What word will help me remember the pattern for the sign of the sum and difference of cubes? That is your SOAP. Same sign, opposite sign, always positive. All right. All right. So we're going to do a second video for page 2. Tune in.